This is cs952 Introduction to Web Technologies and Design, and before we get too far into working on our web pages, let's take a minute to talk about web colors. Now, we're going to talk about RGB, red, green, blue, the three colors that you can use to make just about any color in the rainbow. Now, the RGB color model has been around for quite a long time. Long before the age of the modern computer, television sets used red, green, and blue electrode guns in a cathode ray tube to create all the colors of the spectrum. Combining different levels of these three colors can produce all the colors on a modern computer screen. Combining the colors together at maximum output results in the color white, and all three colors at minimum output produces the color black. Now, most of your web work is probably going to involve the hexadecimal color format. Let's get started with RGB because it's a little bit easier to explain and understand. Now, RGB, is, you might guess, stands for red, green, blue, and that just simply is description of the levels of red, green, and blue. So to display red only at maximum output, you'd use a color definition with 255, that first number, at maximum and the other numbers at minimum. If you wanted blue, then it would be 0 red, 0 green, 255 blue. And white is created by combining all three colors together. So let's go to Dreamweaver. I made a quick style rule for the body of this web page. So we're going to change the color of the background of this web page. And I'm going to click on the background color picker. Click down here. And I'm going to go to my RGB button. Now, we've got three different ways to display the name of our color, but the actual tools that we use to select our color don't change. So it's really just about how do you want to name the color. So again, let's go for 255 for our first number. When we do that, we get solid red. Okay, if I hit enter now, it's about as red as it gets. If I want it all blue, I could change that first number from 255. Whoops. Change that first number from 255 to 255 to 0, 0, and 255, or 100% blue. There's our maximum blue. And then we can get just about any number in between there. If we wanted the color orange, that would be a maximum 255 for our first number, halfway for our second number, and no blue. Let's see, what does that look like? There you go. That's orange. Okay. And then we said if we wanted the color white, and just drag this over here, white is all 255s. And then the color black, just drag this guy all the way down here. It's all zeros. Now, this last number we'll talk about a little bit later, but as I drag this around here, I can actually pick just about any color that I want, and then I can use different naming formats to name the color as well. It's a very flexible system. So let's jump back and keep covering the material in our PDF. We're going to divert here for just 1 second, and you might wonder where that number 255 comes from in the first place. This will give you a little insight into how computers work. First, keep in mind that in the world of computers, we're almost always starting to count with the number 0 and not the number 1. So when we talk about our range of colors, it goes from 0 to 255, which means we really have 256 different colors, right? All zeros, which is the color black, that's a color, and then the number goes all the way up to 255. So really, we're talking about 256 colors. For the level of each color, we've got a range of 256 levels. Remember, computers, everything's always on and off. It's an electronic switch. So imagine you have a light switch. So when the light switch is off, right, the room is dark, and when the light switch is on, the room is fully illuminated. And in the world of computers, if you were going to do this, if you wanted to simulate this, you'd only need 1 bit, because 1 bit has two values. Either it's on or it's off. And remember, at the end of the day, computers are digital machines that only think in terms of numbers being on and off. Well, if we added a second switch, we actually have a range of 4 values now, right? Because we could have both switches up, both switches down, first one up, second one down, first one down, second one up. So if we did this, we'd call this 2-bit color, and it would actually give us a range of 4 different values. And every time we add another switch or add another bit, we double the number of possible light levels. So going through this, 3 bits gives us 8 levels, 4 gives us 16, 5 gives us 32, 6 gives us 64, 8 gives us 128, and finally when we get to 8 bits, we get 256 possible levels. That was a lot of math, and it's not critical to anything that we're doing, but that's where we get 256 different levels. And since we've got these color combinations, it's 8 bits of red, 8 bits of green, and 8 bits of blue. 8 plus 8 plus 8 is 24-bit. So when we talk about 24-bit colors in computers, that's where the term comes from. And it's a combination of 3 colors. And the amazing part is, by varying these 3 different levels, we get 16 million different colors. It's pretty crazy about how many colors we can transmit with just a few simple numbers. So moving on, I mentioned that we have a special extension of the RGB format called RGBA. That's that last number in Dreamweaver. And that last number is called the alpha channel. And what that lets us do is describe a level of transparency. So with normal colors, right, you know, it's like putting paint on the wall. The wall's whatever color you paint it. When we do a transparency, it softens the color. It allows some of the background to show through. So I'm going to take this color that we last used in Dreamweaver. I need to make sure that I'm in RGBA, because RGBA has the alpha channel. And as I move my alpha channel up and down, you can see it shows a level of transparency here in the color picker, and it makes the color slightly transparent. And we're going to be doing that when we work on the website. Having that alpha channel is really nice. Hexadecimal colors do not support this, but the last format, the hue, saturation, lightness, does have an alpha channel. So that's what that A is for. Anytime we need to use transparency, and usually we use transparency like if we have an image in the background, we want a little bit of the image to show through. That's what that's all about. So moving along, we've looked at RGB, right? We said it's 3 numbers, 255, 255, 255, 3 numbers added together. Now the more popular way for us to write these colors is not with RGB, because when RGB, let's look what we had in Dreamweaver, right? We're actually having to write 3 different numbers. Let's go to my RGB format, right? We've got RGB, parentheses, number, comma, number, comma, number, comma, and then if we're using the alpha channel, we've got 1 more number in there. It's a lot of numbers. We could click over here and see the same number in hexadecimal format, and it requires a lot fewer digits. It's easier to remember, it's easier to write, it's easier to relay. This is the predominant format that we use for colors, but it's the exact same color definition as with RGB. It's actually 3 number pairs. The first 2 numbers in hexadecimal, that's the color red, the next 2 colors represent the color blue, and the last 2 colors represent the color green. So if I go back to Dreamweaver, let's jump in Dreamweaver, and let's click on our color picker. I'm going to go to RGB again, and we said all red was 255. Yep, 255, and then 0 for the second color, and then 0 for the third color. That's pure red. Let's have a look at that. Yep, that's as red as it gets. So if we view that same number in hexadecimal format, that number is FF0000. So FF means 100% maximum, 00 means 0, and 00 means 0. What if I put in 00FF00? Well, that's 100% green, right? If I switch over here to the RGB format, there you go, 100% green. The reason that we can do it with just 2 numbers is because the hexadecimal format is written where our numbers range, rather than being from 1 to 10, like we're counting on our fingers, they actually go from 1 to 16. And that's what that's why when we talk about hexadecimal, we're talking that we get to count to 16. So after the number 9, we don't go to 10, we go A, B, C, D, E, and F. And that's why the color white is all FF, 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 because that's 100% maximum color. So hexadecimal colors are basically the same thing as RGB colors. They're just written, in a little bit shorter format. Now I won't go into all how the numbers are actually written out. You can read all that in the text file. But that's essentially the difference between our primary color formats. Okay, RGB is the easiest color format to understand, but we're going to generally find that the colors we work with when we copy colors, when we see colors expressed, they tend to be expressed in the hexadecimal format, but red, green, blue, it's all the same color no matter how you write it.